Hi students, this is our third lesson for the topic of interest and depreciation. In this lesson we're going to learn about compound interest. So far we've learned about simple interest loans and credit cards. Now compound interest is where the interest is calculated on the current balance, not on the initial balance, and it's considered fairer because for loans the interest is calculated on a declining balance, so the more you pay off the less you owe. See, with simple interest it's always calculated on the amount that you borrowed. With investments, the interest is calculated on an increasing balance. So you get some interest, you put it in the bank and your balance increases. And so for this reason, compound interest is sometimes called interest on interest. Here's an example. Mary invests $4,000 into an account that earns 6% per annum. It's compounded annually, and we're going to talk about what that means in a minute. What is the balance of her account at the end of 3 years? All right, we're going to set this up in a table. So I've got the year, we've got our opening balance, we're going to calculate the interest, and we're going to find the closing balance. So she starts off with $4,000. She earns 6% per annum, so we're going to find 6% of 4,000, which is 240, and we're going to add that on. So at the end of the first year, she's got 4,240, and that's the opening balance of the second year. Now we're going to work out 6% of the new balance, so 6% of 4,240. Do you see how we're getting interest on the interest? So that's $254.40. That's slightly higher than it was the previous year. And now we're going to add it together. And the closing balance at the end of the second year is $4,494.40, which becomes the opening balance of the third year. Let's do it one more time. 6% of this gives us $269.66, slightly more because we've got some interest that's been calculated on the interest. Add that together and our closing balance is $4,764.06. Instead of working out though the interest for every year and then adding it on, we can use the compound interest formula, which is here, and it will be given for you on a formula sheet. So this is the amount accrued, and that means the balance. P is the principal, just like in simple interest. R is the interest rate expressed as a percentage, and N is the term. It's the number of times the interest is calculated and added on, and that's that word compounded. Let's see how it works. Find the balance at the end of 3 years if $4,000 is invested at 6% per annum compounded annually. So this means how often we're going to calculate the interest and then add it to the account. Right, so A is equal to P in brackets 1 plus R to the N. Right, this is the principal, so it's going to go in there. The interest rate is 6%, that goes in here, and N is 3 years, so that goes there. Okay, and putting in the calculator, we get $4,764.06, which is exactly what we got through doing it in the table. Notice the difference in the simple interest and compound interest formulas. So here we've got I equals PRN and A equals P bracket 1 plus R to the power of N. So we've got a P in both formulas, we've got an R in both formulas, and we've got an N in both formulas, but what we don't have in both is the I and the A. So the simple interest formula calculates the interest, the compound interest formula calculates the final balance. Okay, don't get that mixed up. Now if we want to calculate the amount of interest earned, we must subtract the amount invested, the principal, from the closing balance. So here's our previous example. Now we want to find the total interest earned. So we know the amount that is accrued, or the closing balance. We just worked that out. It's $4,764.06. How much bigger is that than that? That's the interest. Okay, we put this much in, we got this much out. So $764.06 must be the interest earned. Now there is a shortcut. Instead of using 1 plus R%, we can do this. 1 plus 10% is the same as 1.1. 1 plus 5% is the same as 1.05. 1 plus 22% is the same as 1.22. 1 plus 2.3% is the same as 1.023. Hoping you're starting to see the pattern. What about 1 plus 0.6%? It's 1.006. So can you see the pattern? This is the same as 1.10. If we just write that in really quickly, there's the 10. Do you see it? So 10, 10, 22, 22. In this case, 5 has to go into the hundredths position. Same here, the 2 is going into the hundredths. Here, the 6 is going into the thousandths position. Now, if that's too confusing for you, then just leave it and stick with this. Okay, but it'd be really good if you can move towards doing this by the time you're in year 11 and 12. So let's look at our question that we had before. There's our formula. Instead of 1 plus 6%, I'm going to do 1.06 to the power of 3. Still gives me the same answer. Now, sometimes the interest is calculated more frequently than annually. It can be every 6 months, it can be quarterly, that's every 3 months, or it can be monthly. And this is called the compounding period. It's how often we calculate the interest and add it to the account. And here's the thing, the more often it is compounded, the more money you make, because you get more interest on the interest. But in order to use the formula, we're going to have to change R and N into whatever compounding period it is. So let's practice that. Let's change R, which is 12% per annum, and N, which is 5 years, to half years. All right, let's start with R. 12% per annum is going to be 6% per half year. And how do we change 5 years into half years? How many half years are there in 5 years? Hopefully you're telling me 10. What about we change it to quarters now? So I want a quarter of 12%, or 12 divided by 4, which is 3%. And how many quarters are there in 5 years? 5 times 4, which is 20. And then finally into months. So 12% per annum to a monthly rate is 12 divided 12, isn't it? It's 1%. And how many months in 5 years? It's 12 times 5, which is 60. Here's our first example. Calculate the amount accrued if $3,000 is invested for 5 years with an interest rate of 6% per annum compounded monthly. All right, there's our important words. We're going to have to start by changing R and N into months. Let's start with N. So how many months in 5 years? We just worked that out, didn't we? There's 60. And 6% per annum to a monthly rate, we divide by 12. So I get 0.5%. Okay, we're not finished. We've actually got to put it into the formula now. So here's our formula. P is $3,000. R is 0.5% and N is 60. Let's put it in, and into the calculator we get $4,046.55. Example 2. Fiona borrows $14,000 from a building society. Compound interest of 9% per annum is calculated and added to her account quarterly. How much does she owe after 3.5 years? Now this is interesting because it doesn't actually say compounded anywhere, but this is another way of saying it, added to her account quarterly. So that means we're going to have to change R and N into quarters. Right, we'll start with R, which is 9%. We need to divide by 4, 2.25%. This is a tricky one, 3.5 years, so we need to know how many quarters there are in 3.5 years. So I've done 3.5 times 4, which is 14. Okay, now we're going to put it into the formula. There it is. P is 14,000. R is 2.25%. N is 14. In it goes. And you can see there how I have done the shortcut, but you are welcome to do that instead if you want to. And our answer is $19,116.77. So here's an interesting question. Which gives the most interest for an investment, simple interest or compound interest? So suppose you've got the same interest rate and you can choose between simple interest and compound interest. Compound interest will always be better because you get the interest on the interest. And within compound interest, which one's better? Annual, 6 monthly, quarterly, or monthly? The more often you compound, the more interest that you will earn. Let's have a look at it graphically. Here it is here. So this flat line, this red line, is simple interest. Okay, remember it's sometimes called flat rate interest. These are all compound interest. The blue one is annual, then 6 monthly, then quarterly, and then monthly. So they're all curved and they become slightly steeper the more often you compound. All right, we've got one last bit to go for this lesson, and that's working backwards. So just like with the simple interest formula, we've got to work backwards to find the principal, the rate of interest, and the term of the loan. Let's look at some examples. Peter and Diane are saving for an overseas holiday. How much do they need to deposit today at 8% per annum compounded quarterly in order to have $10,000 saved in 3 years' time? Let's see if we can unpack this question. Firstly, we have an interest rate, 8% per annum compounded quarterly, so we're going to have to change R and N. We have N is equal to 3 years. But what's this $10,000? It's not the amount we're depositing, it's the amount at the end, it's the amount accrued. It's A. All right, before we go into the formula, what we want to do is change R and N. N is 12 quarters and R is 2%. Here's our formula. Let's substitute it in. Okay, what have we got here? A is 10,000. We don't know P. R is 2%. N is 12. I'm going to work this out on my calculator. And hopefully you are struck by how many decimal places I've kept there. Lots and lots. And the reason is that our answer is going to be probably 6 significant figures. Remember, they're non-zero digits. So we need to keep about that many or more as we're working through. So just keep a lot of them as you're doing your interim steps, and then when you get to the end, do your rounding. All right, divide both sides by 1.268242. P is equal to $7,884.93. As a bit of an exercise, try chopping this off at 3 decimal places and see what you get. Do 10,000 divided by 1.268. You'll get a really different answer. But they've only got $5,000. So they're going to place that into an investment account for 5 years. What rate of interest, compounded annually, do they require for their investment to grow to $10,000 after 5 years? All right, let's have a look what we've got. So we've still got an amount accrued, or the amount that they want is $10,000. This time they're going to place $5,000 in the account. That's P. And they're going to do it for 5 years. That is N. So we want to know the rate of interest. Thank goodness it's compounded annually in order to be able to do that. So here's our formula. Let's substitute in. So amount accrued is $10,000. P is 5,000. We don't know R, and N is 5. Okay, we need to solve this. Now, a little bit more complicated because we've got 2 things to move, the 5,000 and the power of 5. We're going to move the 5,000 because it's most by itself. This is a times by 5,000, so it's going to come over as a divide by. So let's do that. So across the amount comes over as divided by $5,000. So 10,000 divided by 5,000 is 2. So 2 is equal to 1 plus R to the power of 5. And now we need to get rid of this power of 5. But how are we going to do that? What's the opposite operation? Well, if it was squared, the opposite operation would be square root. If it was cubed, the opposite operation would be cube root. So the opposite of the power of 5 is the 5th root. So this is what we're going to do. We're going to take it over the other side. So let's cross it out. And it's going to become the 5th root over here, which just needs a little 5 in front, like this. Now on your calculator, that is sitting just here. So you need to go Shift and then that button, and then put the 5 and the 2 in. Okay, it will give you 1.148698, and that's equal to 1 plus R. Taking away the 1 gives us R is equal to 0.148698. Now that's a decimal, we'd like it as a percentage, so we'll times it by 100 and we get approximately 14.87%. But they shop around and they can't find a savings account that's going to give them 14.87%. So the best they can find is 8%, and they've asked us to figure out how many years they're going to have to invest their money in order to get $10,000. All right, let's have a look what we've got. We've still got P is 5,000. We know R is 8%. And we've got A is 10,000. We don't know N. So let's substitute it in. You can see how instead of 1 plus 8%, I've done 1.08. It's up to you. We don't actually know how to solve that equation. You learn that later in year 10 or in year 11. So we're going to use a technique called guess and check, and I'm just going to substitute in values for N until I get the right answer. So I'm going to put 5,000 times 1.08 to the power of something into my calculator. All right, from the previous question we know it's going to be bigger than 5, so let's try 8. It's pretty close actually. $9,254.65. Let's try 9. Now on your calculator, all you have to do is use your arrows and get back up into here and change that to a 9 so you can save a bit of time. No, not quite. What about 10? Yes, there it is. So with these sorts of questions, it's really important to show working out and also answer the question. Say, therefore, they will need to invest their money for 10 years. Okay, that's it for this lesson. In our next lesson, we're going to look at compound interest loans.